Alright, good morning. We'll be discussing today about our second module for microprocessors, fetch, decode, and execute cycle. So as part of the introduction, we would like to emphasize the importance of understanding the fetch, decode, execute cycle in microprocessors and explain that the cycle is fundamental to the functioning of microprocessors. So, microprocessors in computer engineering. At first, i-define muna natin what is microprocessors. So, anyway, nung last time, we already differentiated microprocessors from microcontrollers, but this time, we would like to further define microprocessors in the field of computer engineering. Basically, it is an integrated circuit or IC that contains the functions of a central processing unit or CPU. Kaya nga in our case, we're using Verilog HDL kasi ginagamit yung mga HDL code natin para sa mga IC. It executes instructions and processes data in electronic devices. So ano po ba yung importance ng microprocessors in computer engineering? Basically, it is a central component in computers and electronic devices and responsible for executing instructions and managing data. So the role in executing instructions and processing data, so interpret and execute instructions stored in memory. So laging ganon, there's a part na merong memory, doon kinukuha, yun yung ginagamit to execute yung instructions doon nakastore sa ating mga memory. Manipulate and process data according to program logic. So ito na yung ikaw yung nagbibigay ng logic or ng sequence ng code na kailangan i-manipulate at i-process ng ating microprocessor. So ito yung ating little overview about the fetch, decode, execute cycle. So basically meron tayong 3 stages. Tandaan mo, laging ganito yung ginagawa ng ating regardless kung HDL code ang ginamit natin or assembly language, meron laging fetch, merong decode, and merong execute. So mahalaga na maintindihan natin yung differences ng tatlong stages na to. Yung una, fetch, ginagawa na, kinukuha na yung instruction from the memory. So, available na dapat doon sa ating memory instruction, kukuhanin lang ng fetch na stage. And then the decode part interprets the fetch instruction. So, kukuhanin niya, then i-decode niya yon to a language understandable by the computer. In our case, as we know, binary code, machine language, those are the languages interpreted or understood by the computer. And then the next is execute. Implements the instruction and processes data. So sa ating side, ito yung nakikita natin, yung execution na, 'di ba? So we just give input to the system and then nakikita na natin yung result. So ano po ba yung importance ng microprocessor operation? Basically, this is a fundamental cycle in microprocessor operation and dictates how instructions are fetched, decoded, and executed. So, i-further explain natin yung fetch stage. So, this is the detailed explanation ng fetch stage. So, again, it fetches the instruction from the memory. At kapag ginamit natin yung program counter, so we actually have representation for that using simple as possible computer. So, dadaanan natin yun eventually. So, it utilizes program counter to determine the memory address. Siya yung nagtuturo kung nasaan yung instruction. And then it involves the memory address register and the memory data register. So basically, these are the addresses of the instruction na nakastore sa memory. Ano po ba yung role ng program counter or ng PC? It keeps track of the memory address of the next instruction to be fetched and incremented after each instruction fetch. Kaya nga program counter. Alright. Ano naman yung importance ng MAR at saka ng MDR? MAR stores the address being accessed and MDR stores the data fetched from memory. So take note ha, merong differences. Yung MAR concerned siya dun sa memory address. Yung MDR concerned siya dun sa data na kukuhanin niya from the memory. So after the fetch, yung in-explain natin kanina, we also have the decode stage. So, yung decode stage interprets the fetch instruction at dito na involve yung instruction register IR and it separates the OP code and the operands. Alright. Pag sinabi nating mga opcode operands, ito na yung katulad ng ginagamit natin na syntax or mnemonics doon sa different programming language that we have used. So yung ating instruction register IR simply holds the current instruction being processed. Kasi nga ang register, tandaan mo lagi yung temporary storage ng data. So hino-hold niya yung value ng ating instruction or kung anong instruction yung gusto nating i-process. It also facilitates the separation of OP code and operands. So we have to understand ano ba yung differences ng OP code at saka ng operand. Pag sinabi nating OP code, it specifies the operation to be performed, and the operands naman yung data on which the operation is performed. So yun yung difference ng dalawa. Operation yung OP code, and then the operand is the data that we are trying to execute. And then ito naman po yung ating last cycle, which is or last stage rather, which is the execute stage that implements the decoded instruction, also involves the manipulation of data and interaction with registers and other components. In your case, yung sa ating first experiment, di ba, arithmetic logic unit. So yun, nag-manipulate tayo ng data from that experiment. Eventually, i-interact din tayo dun sa registers using assembly language. Kaya nga meron tayong emulator 8086 para makita natin ano ba nangyayari dun sa mga register values natin. And then, we also have here explanation of implementation of the instruction. So, it's execute the arithmetic or the logical operations or depende kung anong in-specify po natin na instruction. It can also involve data transfer between registers and memory. Kasi we do have a lot of registers. Halimbawa, register A, gusto mong i-transfer yung data to register B and then to a specific memory address. So, pwede po yun. Part pa rin po yun ng execute stage. It also includes manipulation of data. Katulad ng example ko kanina na ginawa natin sa first experiment, the simple arithmetic logic unit or the ALU that performs mathematical and logical operations, and the resulting data is stored in registers or memory. Diba? And then also interaction with registers and other components. Data may be moved between registers during execution. Output may be stored in memory or sent to other components. So, depende dun sa dinesign po natin. So, this is a simple example of instruction execution and we'll walk through this example. Yung nakikita natin, we have 4 columns dun sa ating table. The instruction, the operation, the operands, and the result. So, yung instruction na binigay natin, add R1, R2. So, obviously, yung operation na gusto natin i-perform then addition. And then, we have two operands, R1 and R2. So, kung titingnan natin sa ating programming languages, ito yung mga variables that we would like to manipulate, diba? And then, the result, this is the operation that we are trying to perform. So, simply add R1 and R2. Yan. So, yung ating data and control signals, so these are signals that coordinate the flow of data and control between components. An example would be signal to activate the arithmetic logic unit for addition. So, eventually, habang nagpe-perform tayo ng experiment, kailangan mo yung mga data and control signals. Yun yung magti-trigger kung kailangan nyo nang i-perform yung addition, kailangan nyo nang i-perform yung subtraction, multiplication, division, and so. So, ano naman po yung control unit and arithmetic logic unit? So, yung control unit manages the fetch, decode, execute cycle. Yung arithmetic logic unit naman performs arithmetic and logical operations para hindi tayo nalilito dun sa dalawa. The control unit coordinates the execution of instructions and manages the flow of data and control signals. Normally kasi yung flow ng data dumadaan yan ng communication channel. At yung tawag dun sa communication channel na yun is yung bus. And we do have a lot of types pa ng bus. But basically, yung bus na yun, lahat doon dumadaan yung ating data. Yung arithmetic logic unit performs addition, subtraction, and so on, along with logical operations and or etc. So yung lahat po ng mga logic gates that we've discussed in logic circuits and discrete math. So, ine-execute din po yun ng arithmetic logic unit. Another term na lagi nating maririnig sa microprocessor is the data path. Data path is simply the route through which data flows during instruction execution. So yung dinadaanan, yung ruta ng data from start to end, from fetching to decode to execute. Yan. It also integrates the control unit, arithmetic logic unit, and registers na part ng computer architecture. Kaya nga sabi ko sa inyo, magkapatid ang microprocessors at computer systems architecture and organization. So, lahat po yun, kailangan nating tingnan doon sa data path. The flow of data between components, involved din po yan doon sa ating data path. The data moves between registers, memory, and then arithmetic logic unit, and the control signals guide the flow during each stage. Meron din tayong tinatawag na pipeline architecture. Yung pipeline architecture simply breaks down the fetch, decode, execute cycle into different stages, optimizing the process by allowing parallel execution of stages. Ibig sabihin, parallel, sabay. Sabay nang ine-execute yung different stages natin, yung different instructions na binigay natin dun sa ating system. So, ito yung explanation ng pipeline stages. We have the fetch stage, decode stage, and execute stage. And each stage operates concurrently with the previous one. Ano po ba yung pros and cons ng pipeline architecture? Yung pros natin, increased throughput. And then yung cons niya, increased complexity. And then faster yung overall execution natin. Pero yung cons niya, potential for pipeline hazards. Kaya we have to check these trade-offs. Depende dun sa design na ginagawa po natin. So what are the challenges and the solutions? So yung challenges natin, data hazards, control hazards, and structural hazards, bottlenecks and execution and resource contention. In our case naman kasi, since introduction naman tayo, hindi pa naman tayo pupunta dun sa part na we needed to optimize and consider the different hazards. Kasi hindi naman natin siya implement into a physical device or hindi tayo kikreate ng physical IC and then evaluate after. What else? Solutions and advancements, forwarding, pipelining, and out-of-order execution, advancements in microprocessor design to overcome challenges. Evolution of microprocessor architecture, so from single core, as you know, we now have the multi-core processors, and we do have a lot of types of microprocessor depende dun sa brand. Integration of advanced features, di ba, for better performance as explained in our previous discussion. Ano yung mga real-world applications natin? Personal computers, smartphones, embedded systems, servers, gaming consoles, automotive control systems. Anong importance ng microprocessor sa modern technology? Enabling the functionality of diverse electronic devices, driving innovation in technology and computing. So as part of the conclusion, ito yung mga key points na napag-aralan natin this morning. Fetch, decode, execute cycle is crucial for microprocessor operation. And then understanding the cycle is essential for computer engineers. And then ito yung significance ng understanding the cycle, foundation for efficient and reliable computation, and basis for further exploration in microprocessor architecture. So thank you very much.